Alright, so we have section 5.4, sum and difference identities for sine and tangent. Okay, so here are sum and difference identities for sine. So notice how these are different from cosine. We have sine and cosine, and then cosine and sine for both of them. However, the sine actually matches what's inside the parentheses here. Okay, unlike cosine, if it was cosine of a minus b, then you would have a plus. Okay, so make sure you have these for reference whenever you're taking your quizzes and your tests and doing your homework. Okay, so here we have sum and difference identities for tangent. So these are quotients here, and then a minus b, we have a in the top, positive in the denominator, and then a plus b, we have plus in the numerator and minus in the denominator. Okay, so that's the one difference between tangent of a minus b and a plus b. Okay, so let's talk about how to use these. So we want to find the exact value of each expression. Okay, we want to do this using the identities, of course. So we have sine of negative 15 degrees. So what we want to do is rewrite negative 15 as subtraction or addition so that we can use one of these identities. And then when you're doing this, you want to write it in terms of angles that we already know, such as a 30, a 60, or 45 degree angle, or 90, a quadrantal angle. So negative 15 degrees can be rewritten as sine of 30 degrees minus 45 degrees. Okay. There are other angles, of course. 30 and 45 aren't always going to be the ones that work out. You may need to use an angle that has a reference angle of 30 degrees, 45 degrees, or 60 degrees. Okay, so rewriting it in this form, so we have sine of a minus b here, so a minus b. Okay, so we can plug this into our difference identity for sine. So we have sine of a, so that's sine of 30 degrees, times cosine of 45 degrees minus cosine of 30 degrees times sine of 45 degrees. Okay, at this point you can plug these into your calculator. Make sure that your mode is correct. So here we're talking about degrees, so your mode needs to be in degrees. Okay, so sine of 30 gives me 1/2. And then cosine of 45 degrees is square root of 2 over 2, minus cosine of 30 degrees is square root of 3 over 2, and then sine of 45 degrees is square root of 2 over 2. Okay, so then if I just multiply these out, I have square root of 2 over 4 minus square root of 6. Okay, so when you multiply these together, it becomes square root of 6 over 4, which then I can write as square root of 2 minus square root of 6 over 4. Okay, and then if I was to plug this in my calculator, I would have sine of negative 15, and I am in degrees, equals negative square root of 6 plus 2 over 4, which is the same thing as square root of 2 minus square root of 6 over 4. So that is correct. Alright, so tangent. Okay, so notice now that we are working with radians, so you'll need to change your calculator to radians. Okay, so we have tan of 13 pi over 12, so we want to rewrite this as a difference or a sum identity. Okay, so we can rewrite this as tangent of 9 pi over 12 plus 4 pi over 12. Okay, so this is still equal to 13 pi over 12, which then can be rewritten as, so we're just going to simplify. 9 pi over 12 would give me 3 pi over 4, And then 4 pi over 12 is going to give me pi over 3. Okay, so 3 pi over 4, 3 pi over 4, so times 180 divided by pi. Okay, so this is 135 degrees, which has a reference angle of 45 degrees. Okay, so reference angle 45 degrees. Okay, so that's why we are going to use that one. So generally, whenever you're splitting this up, you're going to want to be splitting it up into values that you have on your unit circle here. So all of these values have reference angles of 30, 45, or 60 degrees. Okay. Alright, so I have a sum identity for tangent. So tan of A plus B. So 3 pi over 4 is A, pi over 3 is B. So we're just going to plug into this formula here. So I have tangent of 3 pi over 4 plus tangent of pi over 3 all over 1 minus tangent of 3 pi over 4 times tangent of pi over 3. Okay, tangent of 3 pi over 4 is going to give me a negative 1. And then tangent of pi over 3 is going to give me a positive square root of 3. So then I have 1 minus negative 1 times the square root of 3. So negative 1 plus square root of 3 over 1 plus square root of 3. Okay, don't forget that we have to rationalize our denominators. So in order to rationalize this 1 plus square root of 3, we will multiply. So let me just rewrite this. So we're going to multiply by its conjugate. So multiply by 1 minus square root of 3. Okay, so that gives me negative 1 plus 2 square roots of 3 minus 3 over 1 minus 3. Okay, so add like terms, and I have negative 4 plus 2 square roots of 3 over negative 2. And then I can simplify this even further to be negative 2 minus square root of 3. Not negative, positive. 2 minus square root of 3. Okay, because if I pulled a negative 2 out on top and bottom, so I have negative 2 and then times 2 minus square root of 3 over negative 2, then I would be left with 2 minus square root of 3. Okay, so for C, okay, so if we look at C, we can notice that this is equal to the difference identity for tangent. So tangent of A minus B. Okay, so we have tan of A minus tan of B, and then 1 plus tan A tan B. Okay, so then we can say that this is equal to tangent of A, which is 100 degrees, minus B, which is 70 degrees. So it's going to give me tangent of 30 degrees, which is equal to square root of 3 over 3. Okay, so we just noticed that this was in the form of a difference identity for tangent. Okay, example 2, write each function as an expression involving functions of theta alone. Okay, so here we have sine of A plus B. Okay, so then we're going to rewrite this where A is 120 degrees and B is theta. So we're going to rewrite that as sine A cosine B minus cosine A sine B plus, sine A cosine B plus cosine A sine B. So then we have sine of 120 degrees cosine theta plus cosine of 120 degrees sine theta. Okay, well, we know sine of 120 degrees is square root of 3 over 2. Okay, and we don't know what cosine theta is. So we're just going to bring that down. Plus, cosine of 120 degrees is going to give me negative 1 over 2 times sine theta. Okay, so then if I just add these together, I have square root of 3 times cosine theta minus sine theta all over 2. Okay, and then that would be our answer for example 2. Alright, so we have tangent of theta plus 3 pi. Okay, so this is the sum identity for tangent. So tangent of A plus B is equal to tangent A plus tangent B over 1 minus tangent A times tangent B. Alright, so we're going to plug this in. So we have tangent of theta plus 3 pi. So theta is A, 3 pi is B. So we have tangent theta plus tangent of 3 pi over 1 minus tan theta times tangent of 3 pi. Okay, so we have tangent theta, and then tangent of 3 pi is 0. So then on the bottom we have 1 minus tangent theta times 0, because tangent of 3 pi is 0 again. Okay, so this is going to leave us with tangent theta over 1, okay, because tangent theta times 0 is 0, and then 1 minus 0 is 1. So then our answer is just tangent theta. Alright, so for C we have sine of theta minus 270 degrees. So this is going to be the difference identity for sine. So sine of A minus B is equal to sine A cosine B minus cosine A sine B. Okay, so here A is theta and B is 270 degrees. So if we plug that in, so we have sine of theta minus 270 is equal to sine theta times cosine of 270 degrees minus cosine theta times sine of 270 degrees. Okay, so I have sine theta, cosine of 270 degrees is 0, and then sine of 270 degrees is negative 1. Okay, so this is going to be 0, and then I have a minus times a negative 1, so it's going to give me a positive cosine theta. Alright, example 3. Suppose that A and B are angles in standard position such that cosine A is equal to negative 7 over 25. A is between pi and 3 pi over 2. Okay, so that means that A is in quadrant 3. And sine B is equal to negative 3 over 5. So that means that B is between 3 pi over 2 and 2 pi. So that is in quadrant 4. Find each of the following. Okay, so first we want to find sine of A minus B. Okay, so we know from the difference identity that this is sine of A cosine B minus cosine A sine B. Okay, We know cosine A and we know sine B, but we don't know sine A and cosine B. So first we need to solve for those. Okay. So first, if we want to solve, we have sine B is equal to -3/5. Okay, if we use our Pythagorean identities, then we can do sine squared B plus cosine squared B equals 1. And then plug in for sine squared B. So -3/5 squared plus cosine squared B equals 1. Okay, or cosine squared B equals 1 minus -3/5 squared. So that would be 9/25. So cosine squared B is equal to 16/25. Okay, but we need to find cosine B, so we take the square root of both sides. So cosine B is equal to the square root of 16/25. So the square root of 16 is 4, square root of 25 is 5. And then we need to determine, is this positive or negative? Okay, so B is in quadrant 4. Okay, cosine is positive in quadrant 4, so this is going to be a positive 4/5. Okay, so then we want to find sine of A. So we have cosine of A is -7/25. So using this same formula here, but now instead of A we have, now instead of B we have A. So sine squared A plus cosine squared A equals 1. Okay, so we have sine squared A plus -7/25 squared equals 1. Okay, so I just plugged in for cosine A. And then we have sine squared A equals 1 minus -7/25 squared. Okay, so 7 squared is 49, and then 25 squared is 625. So that means that sine squared A is equal to 576/625. Okay, so it's just 1 minus 49/625. And then we take the square root of both sides. So then we have sine A is equal to the square root of 576. So the square root of that is 24. And the square root of 625 is 25. And then we need to determine our sine. So angle A is in quadrant 3. Okay, so sine of an angle in quadrant 3 is going to be negative. So sine A is -24/5. Alright, so we are going to plug back in now. Okay, so sine A is -24/25. Cosine B is a positive 4/5. Cosine A is -7/25. And then sine B is -3/5. Okay, so from here we just multiply everything out. So we have -24 times 4. This gives me a -96/125 minus a positive 21/125. So I get a -117/125. So that's my answer for sine of A minus B. Okay. For tangent of A minus B, we have, so this is the difference identity for tangent. So that's going to be equal to tangent of A minus tangent of B over 1 plus tangent A times tangent B. Okay, so we just need to find tangent of A and tangent of B. So tan A is going to be sine A over cosine A. So that's -24/25 over negative 7 over 25, which is going to give me a positive 24 over 7. So tan B is sine B over cosine B. So it's negative 3 over 5 over 4 over 5. So that gives me a negative 3 over 4. Okay, so then I can just plug these values in for tangent A and tangent B. So I have 24 over 7 minus negative 3 over 4 over 1 plus 24 over 7 times negative 3 over 4. Okay, so this gives me 96 plus 21, 28, and then I have 1 minus 72 over 28. Okay, so I'm going to rewrite this down here, add those together. I have 117 over 28 over, subtract this denominator, so negative 44 over 28, which is going to give me 117 over 28 times the reciprocal, so over negative 44. So this gives me a final answer of negative 117 over 44. Okay, so this is tangent of A minus B. Alright, so then the last question says, what is the quadrant of A minus B? Okay, so if we look at part A, we know that sine of A minus B is negative. Okay, sine is negative in quadrant 3 and quadrant 4. From part B, we have that tangent of A minus B is negative. Okay, and tangent is negative in quadrant 2 and quadrant 4. Okay, so that means that A minus B must be in quadrant 4.